Hello everyone and welcome to today's workshop on Asia for the Copernicus Marine Service. So my name is Gaëlle Enat-Sterbik and I'm a training officer at Mercator Ocean International and I'll be your host for today. So over the course of this training, we will explore key aspects of the Copernicus Marine platform and its data. And on today's session, we will tell you about what the Copernicus Marine Service is about, what sort of data and projects you can find, and what sort of applications you can do with it. So before we start, let's quickly go over some house rules and guidelines to make sure you enjoy this webinar. First, we ask you not to use the chat that you see on your right-hand side for your question. You can use it for small talk or say hello to us, but if you have a more technical question or content-related question, we invite you to use the dedicated Q&A section, which you will find on the website. So if you go on the webpage above, you will see the Q&A button available, and when you click on it, you will open the dedicated space where you can ask our speakers your question. And while you're there, you will also see a quick survey about this training workshop. About this training workshop, so just next to it. So feel free to fill it out anytime during the session. Concerning the agenda of today, we will have many interesting presentations, and we will start with an introduction of the Copernicus Marine Service, and then we will have a presentation of the MyOceanPro Pro by Rezak from Mercator User Support. And after that, we will have 3 presentations about specific applications of these Copernicus products. So we will start with Raj Kumar from Ozone Space EdTech. Then we will have Lars Hole from the Norwegian Meteorological Institute. And finally, Shihe Ren from the National Marine Environmental Forecasting Center of China. And let's start with the introduction to the Copernicus Marine Service that I will give you. So, Copernicus is the Earth observation component of the European Union space program, so dedicated to monitoring our planet and its environment. It provides free and openly accessible information services based on satellite observations and in-situ data, helping service providers, public authorities, and organizations to improve the quality of life in Europe and beyond. So Copernicus operates through space-based and in-situ observations component and offers dedicated information services through self-standing portals tailored to various user communities. So how do you access the website? So it's free to access the website and download any product at this address. There you will find an extensive catalog of products. All of them are scientifically qualified and user-driven, so they are constantly upgraded and improved. And considered is also taken into account the experiences of users of the services to improve the datasets. The kind of data you can find on Copernicus Marine. So it provides data on the blue, green, and white oceans. So the blue is all about the physical components of the ocean, so currents, winds, waves. Then you will have the green ocean, which is about the geochemical component of the ocean. So all that has to do with phytoplankton, nutrients, chemical composition. And finally, the white ocean, so everything which is related to the ice. You can find these are just a few examples, and also in terms of temporal and geographical coverage and the type of data the Copernicus Marine Service provide, it is quite varied. So it includes in-situ data, satellite observations, which are then used to validate model data. Then you can find data that are measured right now, so real-time data, but also from the past all the way back to 30 years, so what we call reanalysis or multi-year data. And we also provide forecast 10 days into the future. And also in terms of geographical coverage, we do cover 5 or 6 regions. So we have the global region, which is all around the globe, and we have also smaller region around Europe. You will also find on the website a visualization tool what we call MyOcean Viewer. So you have 3 versions of this visualization tool, the Learn, the Lite, and the Pro, and we will have a demonstration of the Pro today. And it's just to show you how you can select a product and see it or visualize it in a fun way. We also provide specific products like ocean monitoring indicators or data related to the climate. So in this case, the monitoring indicators are key variables that help us understand the state of the ocean. So they are also accessible and free of charge, and they cover the last 30 years. And beside data, we also provide information, and one of the ways that we do that is by publishing a yearly report on the state of the ocean. So we will provide the Ocean State Report Summary, which is a summary of the annual report we do, and we try to target non-scientific communities like policymakers or just the general public. Also, to make sure that the information gets to everyone, we do that by creating 2 pages called the Ocean Explainers and the Ocean Climate Portal, where we explain some oceanographic concepts or current threats that the ocean is facing, and we try to basically explain it to everyone. So as you can see, we try to reach a bit of everyone, and it's the data that we provide and its information. It responds to different needs or markets, so we call it the blue markets, and it goes from science and innovation to policies, but also to coastal services or economy sectors. And yeah, concerning the use case, or for example, today you will hear about 3 practical applications of the data we provide, but on the website you will find many other examples, and we invite you to visit the website and learn from these examples. And if you are a use case yourself from Copernicus data, we also invite you to submit your project as a use case. So we are always interested to learn more about how the data have been used. So we will put in the chat an email address to where you can send your use case if you wish to submit it. And finally, we also try to make sure that the data is not only available to everyone, but that we can help people use it. So we try to make it as accessible as possible. So we organize workshops and webinars like this one, but we also organize hackathons or forums and other type of events, and we try to engage with the users. So that's all for me for today, for the introduction. And if you have any questions, don't hesitate to ask them in the Q&A section, and we will go to the next speaker and next presentation, which is Rezak from the user support to present you the MyOceanPro Pro. Welcome, Rezak.
Thank you, Gael.
And you can start sharing your screen and do your presentation when you're ready.
Okay. Can you see my screen?
Yeah, we can.
Perfect. So, good morning, everyone. I'm Rezak from Copernicus Marine User Support Team. So today I will be presenting one of the main tools used to visualize and retrieve Copernicus Marine data, which is the MyOceanPro Pro. To access it, it's really simple. Just go to our site, Copernicus Marine, and then go to the Access Data section here and scroll down to Ocean Visualization section, access it, and then as you can see, we'll be getting 3 different versions of the tool. So first we have the MyOcean Learn, which is more like a beginner version of it. And then we have the MyOcean Lite, which is an intermediate version. And finally, we have the MyOcean Pro, which is the version that contains all the main features and options that you can use to have the best possible experience when visualizing, also downloading our data. To access it, just click on it here, and then you will be getting to our to the interface of the tool. Once on the interface, as you can see, we have many options to explore. So first, you can maintain your mouse and drag up and down, or to the left or to the right. You can also zoom in or zoom out with your mouse wheel. As you can see, also, you can change the projection. So you can switch to the North Pole projection here in case you are studying a variable within this region to get a better access to it. You can switch back to the equatorial projection, and then you can go to the South Pole projection as well. Here at the bottom, we have the time scale. So the time scale contains the different date in which the variables are available. So you can simply change the date to visualize the variable at a given date. Of course, if you select a date out of the scale, as you can see, then you won't be able to visualize the variable. It's simply because this one is not available within this time range. Here on the left, on the right, also we have a small scale that indicates the depth. Same thing, in case you need to select a different depth to your variable to display, just maintain this narrow with your mouse and select the depth that suits you. Here on the left, we have the windows that contains the different layers containing the variables to display. So here the eye contains the variable, in this case the seawater potential temperature. So as you can see, the small eye here, when the eye is blue, that means that the variable is displayed. And when it's not, in case you want to hide it, just click on it and the variable will be hide. Also here we have two different variables, two different layers. In case you need to alter the order between the two, just drag with your mouse here and change the order in case you need or you want to visualize a variable first from another. We have here also a small functionality which allows to delete or remove a variable, remove a layer. Just click on it and the layer will be removed. Here we have an arrow that allows us to hide or show the window in case you need to have more access and more space to visualize all the regions. And here we have also the name of the variable, and below we have the date and the depth that we have selected. So now I will show you how to add a variable to visualize it. For that, it's really simple. Just go to the plus here, add a layer, and click on it. And then you will be accessing our data store in which nearly 300 products are listed. So we have data from models, from satellites, and also from in situ observations. And as you can see, each product is characterized with some information. We have the spatial extent, the temporal resolution, as well as the variables contained in it. Here on the left, we have the filter section. The filter section basically allows you to help you to get the best to get the variable that you need. So you can select the time range, you can select the depth, you can select the universe, the variables, as well as the temporal resolution and other information. So let's give it an example. So for today, we will explore the global ocean region and select the variable velocity. We will display the velocity variable. And let's say that we will select here from the temporal resolution section, select the daily velocity. So now we'll be getting a selection that matches my filters. And in this selection, you can choose the products that suit the most your needs. So for that, let's say that we will take the global analysis and forecast. So when clicking on it, you will be getting an overview which defines the products as well as all the metadata contained in it. All of this is included within the description section. Here below, the notification section allows you to access the incident, the maintenances that occurs on the product. Data access section allows you to get all the data sets as well as the variables contained in it, each one, of course, with its own temporal extent, and each one gives you access to the three different services. So we have the subset, the files, and the maps service. Contact allows you to reach out to us in case you need further assistance. And here below in the documentation section, we have some documents that contains further scientific details in case you need to learn more about the product and what includes and what is included in it. Of course, we have also the roadmap, which gives you access to the future releases of the products, lists on how to cite, allows you to cite the product in case you are publishing an article. Here we have a small share icon in case you want to copy the URL of the product and share it. So let's now click on Add to Map, and then we are going to get the different data sets with different time resolution. So as we mentioned, today we're exploring the daily velocity. So for that, scroll down to the daily temporal resolution and select seawater velocity. Click on Add to Map, close the window, and as you can see, my variable is added. So now here below, as you can see, we have 5 different icons, of course, each one with its own specificity. So the download icons allows us to download the data, which I'm going to present in a few minutes. The information icons allows us to get an overview of the product, basically landing to the page that we visualized seconds ago. And here the gear icon allows, the layer icon allows to get the other different data sets contained in the product. So this one, in case you need to change the variables to display, so you can check this one and select it. The gear icon contains some options to characterize your visualization. So let's say that you want to change the opacity, simply drag with your mouse and change the opacity. Of course, same thing for the styles. So we have here different styles that you can use. So we can use solids, as you can see. We can use particles plus solids. We can use only particles. We can also use vectors. Here on the hatching style, we can also use the hatching style visualization. In this one, we can explore many various options. So to get better access, we're just going to visualize this section here, this region. So within the hatching style, we can select a value of the seawater velocity from this scale. So this scale contains the different values of the variables we are displaying. So let's say 0.93. So here I can choose to only show the values equals to this one, or the values that are not equal. As you can see that all the values that are not equal to this one are selected within the scale. You can also choose to select the greater or equal to this one also. Same thing, smaller or equal. And we can also select the range. Of course, within the range, we can select the minimum and the maximum value. And within this range, I will be getting all the values that are included, as you can see from this scale. Same thing, we can select all the values that are not included within this range. And then, as you can see in the scale, I will be getting all the related values. So that's it for the hatching styles. The color map, we can change our color map based on the color that suits us. Feel free to choose the one that suits you. Here, this option allows to invert the color between the maximum and minimum value, as you can see it from the scale here. The steps option allows us to add also some thresholds in case you need to add thresholds or remove thresholds. Of course, feel free to select the values that you want. And finally, we have here the option to mask the outliers. So this option allows us to mask all the values that are not included within our range. For that, you just click on it, and as you can see, now the values are included. If I want to mask it, just click on it, and these values will be masked. And here, finally, we have the log scale. In case you want to disable the log scale, click on it. You'll be getting the related visualization. Again, if you want to deactivate it, just click on it and it will be deactivated. So now let's switch up to selecting the points. For that, we're just going to go to the Asian region. So to select a given point from the interface, it's really simple. We have three different options. So we can either select a point from the interface like this. Just going to hide this one to get a better visualization. We can also select lines like this. To disable the option, just click on the escape button on your keyboard like this. And we can also select areas. For the area, just going to draw on a given area here. Let's say this one, escape, and that's it. And as you can see, each selection contains the different information. So we have the values of the variables, and also we have graphs that contains the evolution of the variable in a given time. So within this one, we can also explore some options. So we can maximize or also remove all the graphs. We can also adjust the axis or export the selection to an HCTF, CSV, or SVG format. For that, you have to be logged in. So let's say I'm logged out, as you can see, and now I am no longer able to export it. So again, you have to be logged in to be able to enable the exportation options. Of course, we can also merge a selection within another. Let's say we want to merge these two, just drag with your mouse and put it on the top of the other one, and you will be getting the information related to the two selection merged. Here on the import option, you can choose to select presets. So presets are basically predefined region that you can explore on the interface. Reset allows you to export those presets that you have selected. You can also choose to import a WKT, a GeoJSON, or a shape file. Settings here allows us, as you may see, to log in or log out, change the language, or change your map based on the one that suits you. You can also manipulate here some information related to geometry, to units. Feel free to explore it to get the visualization that suits you. All of this is basically related to the styles and to the parameters that you want to use when visualizing your data. So going back to our window here. So let's say I want to download this data now. As I have said, you can go to the download icon here and select your geographical area. So for that, you can use it manually and fill it, or you can use it automatically by clicking on the define all map option and go, let's say, to the surface that I have selected and click on it. As you can see, the geographical areas are automatically filled. Same thing for the date range. You can choose to put it manually, start date and end date, or you can do it as in map. So let's say that we want to download the data from 24th of April. Just click on add in map. 25 as in map, it will be selected to the 27th April 2025. Yes, the 29th in this case. Okay, so let's say that we want to download this one, the start date and end date. Same thing for the depth range. You can select it manually here, or you can do it and like as in map to download. As for the downloading process, it includes three different options also. You can use the browse file service. So this one allows you to get the original data. So just keep in mind that within this one, you cannot select a subset of data. It means that you cannot select a specific geographical area within specific variables. You will have to download the whole data sets and the whole variables contained in it. This one is included within the functionalities of the Copernicus Marine Toolbox that I will go to present next in my second presentation. Second, we have the automate option, which allows to generate two different templates that you can use in two different supports, in the command line interface supports or within the Python API support. Same thing, this one is included within the subset service of the Copernicus Marine Toolbox, which I'm going also to present next. So basically, this information matches the selection that I have chosen here in my region, and this one allows us to download, unlike the browse file service, this one allows us to download subset of data. Finally, we have simply the download option here. To click on it and our data will be downloaded. And just keep in mind that when downloading the data from the graphical interface, there is a quota limit memory that we don't have to exceed, which is 800 megabytes. Unlike when using the toolbox, which is of course one of the many advantages of the toolbox, is that we don't have a quota memory limit. So that's it for the downloading process. And also, if you go back to the top of the window here, we can see that we have also 3 different options that we can explore. So the information icon allows us to get an overview, definition of the MyOcean Viewer tool. And also, we're going to be getting here some keyboards and mouse tips that you can use to optimize your activity and have the best possible experience when using the viewer tool. The share icon here allows us to share your activity. You can share it via a link, image, a video, or an embedded link, which is a pretty cool option that allows you to share your activity. Let's say that all this activity that we have demonstrated today, we want to share it with a colleague. Just select the option that you wish to use and share it. And finally, here we have the message icon. When clicking on it, you will be landing to our user support interface. So as you can see here, we have many different options that you can explore also. So let's say that you need to get started with the tool. So you just have to go to the message icon here and ask a question to Blue, our chatbot. And let's say that you want to inquire more information about the tool. Just type in how to use MyOcean Viewer tool. So Blue is going to explore our data center and will try to find the best possible answer based on the question, of course, that you have asked. And as you can see, it will list the main steps to follow to get started with the tool. And if you take a look here, Blue always tend to join some sources that will guide you to articles generally that you can select, that you can access to get a better view of on how to use the tool. In this case, we can check this article, Introduction to MyOceanPro Viewer, which I recommend in case you need to get started with the tool. It contains all the main features that we have covered in details, of course, with examples and how to use each option, how to select a layer, how to select a variable, such information. I think that would be more than enough for you to get all the needed information to get started, get all the possible knowledge, and have all the information needed to download your data and also to browse the different data sets that we have in our data store. Of course, if the information isn't enough for you, you can always try to explain more your question to help Blue to give you the best possible answer. If it's still not satisfying for you, you can always type in, I want to talk to a person or a human agent, and then you will be getting in touch with one of us, the user support team, and we will be glad to help you out. So I think that's it. We have covered all the main features and options that we can use to get started with the tool. I hope you have enjoyed this presentation. If you have any questions, please ask them. I will be glad to answer. And thank you, everybody.
Thanks a lot, Razak, for your presentation. Oops, it was really interesting. And yeah, we have a few questions for you. So I will start with the first one. So what is the resolution of the project you presented, I guess, the pixel size is really visible?
So each product is characterized with its own resolution. As I said earlier, when you select the product, you will be landing on the product page. In this one, you have various metadata related to the product, and one of those metadata is the resolution of the product. You can check it, and you will be getting the info. So yeah, it's all the information are available in the product section.
Okay, thanks a lot. We go to the next question. Can we save our progress or history to continue our work later or to make some corrections or edits?
Yes. So when using the Viewer Pro, generally the work is automatically saved unless you didn't close the tab or something. Your work is automatically saved. But if you want to ensure to save it or to keep it, you can always try to share as I've shown with the share icon. Share your activity via a link. You can send it to your colleague or send it to use this link as a way to save your work. So yes, it's
Okay,
possible to save your activity on the viewer.
okay, thanks. Good to know. Okay. Uh, so for now, it's the last question. So is my Ocean Viewer available for download and compatible with other visualization software? Also, which operating system do you use to run it?
I think the tool by itself is not available for download. I don't know if we have an application to download and use. Is the user trying to say, is there an application? I mean, that we can
Yeah,
download and
I guess it's is there an application of my Ocean Viewer, which would be no.
yes,
Um,
in this case, yes, it's a no. And as for the operating system, I'm not sure the one that is used to run it, but the user can join us via the chat in the user support interface. We'll check the question and give it the answer.
okay. Isn't I think it's with JavaScript that the viewer is
I want to see with JavaScript, but yeah, just to confirm it, yeah, the user can ask his question via the chat, and we'll be give it the answer.
Okay,
Yes.
thanks. Another question. If we are conducting analysis and the spatial resolution between the projects is different, should we resample first? So more technical, scientific question.
If we're conducting,
But yeah, I guess if
yes,
you want,
yes.
yeah.
Yes, if you want to use different spatial resolutions, it's completely logical to resample first. And yes, it's more like a scientific question. And for this kind of question, requires some investigation to get first to get the information on which products that we are trying to use. And based on that, we will be give it the best method to perform the resampling process.
Okay,
But yeah, I would say that
thanks.
it is possible to do so.
Mm. Okay, so the next question is a question we have, I think, at every event. Can we upload our study area in shapefile format?
Yes, it is possible to import a shapefile and use it to explore it within the viewer. Yes.
A really nice, a really nice tool. Um, this question, what are the accuracy and uncertainty levels of the data? I guess we can find this information with the resolution info and everything, no?
Yes, I mean each product is characterized by its own specificities, like I said, and to find further scientific details on each product, you can always check. It's always recommended to check the user manual and the quality information documents contained in the documentation section within the products page. as I mentioned earlier when I was trying to add the layer. So yeah, such information can be found there. Of course, if the information isn't there, the users can always again reach out to us, and we will be investigating further to get the information.
Okay, thanks. Okay, we have two more questions. What data source does the database use, like a satellite or an observation center? So the data available on the catalog are from different sources. We have in situ data from Argo, satellite boat. We also have model data that we do with the satellite data. So
Yes.
yeah, there is all sorts of data, and you can find the detail of each product of where it came from on the product information also. So don't hesitate to have a look at that if you're interested in seeing where does the product come from.
Yes, exactly.
Um, okay, another question. Can we download the data in netcdf format also?
Yes, data is said to be downloaded in netcdf formats. So you can do so by using the Copernicus Marine Toolbox, which I'm going to present next in my second presentation. You can also export it via the graph option. Like I said, when selecting the point, the line, or a surface, you can go to the 3 points in the graph and choose to export it either in netcdf, CSV, or SVG format. So yeah, netcdf is the format in which the data is downloaded.
Thanks. Okay, so thanks for the nice presentation. Can we compare the level of water either increase or decrease trends over the 30 years or more through this data? I would say
Yes.
yes.
Yes, for that you can choose another variable. You can choose the sea level variable. There are many products that include this variable. So based on the region that you wish to explore, of course, the period, you can select this variable and explore it within I guess in the question is 30 years. So yes, you can choose products that contains historical data and then take the sea level variable and explore it. So yeah, it's possible.
Okay, okay, thanks. Um, I guess another question about the information of the products. How can we be sure that your sources are trustworthy? So I guess also on the information of the product, you can check how the data has been verified and everything. So yeah, we also advise to read all of the documentation coming with the dataset you want to use. Everything is detailed inside, if I'm not mistaken.
Yes, exactly. You can check always. We always recommend the users to check first the user manual and the quality information document specifically, because these two contains all the necessary scientific details that needs to be known on the product. So yeah.
Okay. Thanks. Um, so we have time for two or three more questions. How to get archive data, like for instance, some data has been upgraded in resolution. Can we get the old data set with the previous resolution? I don't know actually.
I mean, that depends on the product. Some products contains all data sets that are always being available, and some products it's not the case with it. So there are products that have been upgraded, which means that the old data sets have been dropped and the data is no longer available. But there are some cases when a user can contact us to inquire to request historical data. In this case, we always try to find the workarounds uh, to get the historical data to the user. But yeah, it's a process that takes that requires to us to to reach out to the producers to get the information, if it's possible or not, to get those old data.
Okay. Okay, thanks. Okay, another question about the shapefile. Is it possible to download shapefile data for all of the variables?
I would say yes. I mean, we didn't try it with all the variables, but yeah, yes, I would say, since the shapefile is since it's possible to use the shapefile to import it and use it within the tool, then I would say yes, it's possible.
Yeah, except if you don't have data on the points you want to download, but otherwise it should be fine, I guess.
Exactly, yes.
Okay. And a more general question, is it possible to use Copernicus data for erosional studies? And what is the possibility of using Copernicus data with software like ArcGIS and GSAS? So on erosion data, I don't think we have like real erosion data. We have like the coastline and everything, but if you want to study erosion, you will have to do some calculation, I guess. But you can use the data with ArcGIS, I guess.
Yes, the data is completely possible to use ArcGIS or QGIS. For DSAS, I'm not sure, but yeah, for you can save the question, we'll investigate it, we'll check it, we'll give it the answer for this one.
Okay.
Yes, yes.
Okay, I will put the question on the side and thanks. So we will have to stop there for the question. We have a few unanswered questions, but don't worry, we will put them on the side to provide later answers in the post-event report. So yeah, thanks again, Rizak, for your participation, and we'll see you around.
Thank you. See you.
And now we will go to the first use cases of today, which is Raj Kumar. Welcome, Raj. And yeah, you can start your presentation whenever you're ready.
Yeah, good morning, everyone. Myself, Raj Kumar. I will be giving presentation of the utilization of this CMAPS data, Copernicus data, mainly some of the products related to ocean. What we are doing in ISRO, the Indian Space Research Organization, Space Application Center, Ahmedabad. So these are the some of the slide. Yeah, sorry, it was some delay. So yeah, first I will just presenting what is the overall what we are doing in not only the oceanography. This is a Space Application Center Ahmedabad. We are doing not only oceanography, all type of remote sensing for the societal application like food security, ecosystem, agriculture, forestry, and atmospheric sciences, environmental sciences related to air pollution. Then some of the climate study, which are the essential climate variables related products, what we are generating, which we can use. And the renewable energy is one of the major things now in all over the world. So we are in India also, we are solar energy, wind energy, this anyhow we are using. But in addition to that, some of the ocean energy also we are making studies. So those also is the part of that. And oceanography, as this will be a whole session itself, so deep ocean as well as the coastal ocean, what are the problems are there we are facing, and then how to solve through the remote sensing and satellite data, as well as some of the institute that we are studying. Hydrology, one of the major water problems, not only on the rivers and lakes, but on the whatever the coming from the snow glacier, that is cryosphere studies, and the geoscience study. These are the major studies what we are doing for societal applications in Space Application Center. And for that, as you know, first we have to get the data, that is from satellite, we are retrieving the data. Then we have to calibrate, validate this data. So that is the major studies what we are doing. And then application of this data directly to the applications, what I was talking about, all these application, and through the modeling studies for the ocean modeling, different type of study, and assimilation of these data. So these are some of the studies what we are doing. I will be talking about. And for all these things, we need to use satellite data. So many satellites we are using from the our partners from all over the globe of space agencies. But from ISRO also, we are having so many satellite data, mainly for, I'm talking about the data, what we are using for atmosphere and ocean. So this the data from the geostationary satellite, like earlier we had Kalpana, now INSET series is there. Presently, they are 3DS are there, and will be other satellite fourth generation will be launched. And the LEO satellite, that means the polar orbit satellites, we have presently OceanSat 2, mainly for the oceanography, which is an ocean color monitor, as well as the spectrometer, which gives the winds. And we have we have the in partners with the CNES as well as the NASA. Many of you may be hearing that we are going to launch next month NASA ISRO synthetic Pachada, which is very beautiful satellite that we'll be having. But in addition, EOS-04, what the Earth observation satellite, I was talking about, we are having synthetic aperture radar. Then OceanSat 3 was there, it is still working, and EOS-07, that is a humidity sounder, and EOS-08, that means many satellites are there. I will not talk each about them, then you can see all those things later on also. And this data is mostly available in the site. You can see the site mosdec.gov.in. All these data, some of the evaluated products one can get from that. So this is just very, very brief about the organization which I worked for the 40 years. This is Space Application Center, Indian Space Research Organization. And presently I am attached with the one company, which is Ozone Space, EdTech and applications. What we are going to do in this ozone space is mainly we are seeing that many education is very like Copernicus is doing this webinar for this data product, but not only for our data product, but all over the space related activities, as well as what are the opportunities for the research scholars there. So we are trying to solve this through the education, like some of the courses we are doing, short courses, workshops and seminars. So we have started these things, and not addition to education, we are also trying to do this, some of the applications also we will be doing through this. Yeah, so presently about about the organizations, I will be not talking about this. So what oceanography studies we are doing in ISRO overall. So left hand side, you can see which are the satellite data we are currently in use. In the black color, you can see these are being used: EOS-06, EOS-04, EOS-08, Saral Altica, INSAT, and some of the satellites which are with the other agencies what we are using, and the future data will be used. So as I told earlier, all this data we are using for the retrieval of the parameters. That means the parameter what we get from the satellite, we have to get for the users what in their format. And then before that, we have to calibrate, validate data. So that is our major work. Then development of applications for this data, so directly users can use it. In addition to that, what are the satellite sensors are required? That means we have to study which are the particular sensor, which frequency, all those things study. That is called OSSE, that means the ocean services. For this, what type of sensor definition we have to do, and then the climate studies, all these things we are doing. And there are many users we are having within India, like Indian Navy Shipping Corporation, as well as some other government agencies and academic research institutes. For this, we are using our data, as well as Copernicus Marine Monitoring Service. As Rajat was talking very beautifully, he explained all this what data are there. So some of the data set we are using for the purpose of validation and applications, as well as the climate studies. And that itself, I will be showing some of the application what we are using, how we are using this data. So one of the product what we are using is significant wave height from the CMMS for the validation of our own satellite, which is the GNSS, that is Global Navigation Satellite System reflectometry. This reflectometry gives the significant wave height itself from the through the reflectometry, that is not the GNSS, but reflectometry. This is the instrument, so that we are trying to derive the significant wave height. Advantage is that we can get a lot more data than the normal altimeter. So that is a major advantage. So we are doing this validation of these things through CMMS data, that you can see this in the slide. Some of the altimeter data we have tried to compare, and these are the presently data in the experimental board, and shortly it will be the operational also. In addition to that, altimeter data is being used for the Saral Altica altimeter, which is since 2013. This satellite is working beautifully. So it has a different mode, because earlier it was in exact repeat mission mode for the geoid applications as well as oceanography application. But later on, it was in drifting phase, and now because it is an old satellite, so there are some issues, so it is not mispointing phase. So because for users, we have to give the data so that they can believe that whether they can use the data authentically. So we have tried to compare this data with the other data like CMMS data. We have compared all this merged data. So you can see in these three pictures how this good the errors are there within that. And now, as I told, that mispointing phase, there errors are more, but earlier phase it was very good satellite. So these are one of the applications of how you use this CMMS data for this. In addition to that, sea level, as Rajat was also talking about, that a lot of products are available for the sea level. And recently, you might have heard the SWOT satellite was launched. That is a very wide swath, and as well as the higher resolution altimeter. So in this, we are trying to compare for the mainly the coastal regions that data is being used, as well as for hydrology purpose for the lakes. And even I'm not showing that part, hydrology part, but ocean part. You can see that a lot more variability has been explained by the SWOT data. So for this data also, because this is a new satellite, we have to validate this data. So for that validation, we have used the product from the CMES sea levels. This is one example of that. Yeah, in addition to that, one of the major part is the currents. Ocean currents is one of the major things, as well as the salinity. So we have developed one product through the Lagrangian coherent structure. And then we wanted to see the dynamics of the sea surface salinity and the currents, whether they can explain some of the features and some of the processes. So for that, we tried to use this data from the CMS and then sea surface salinity data, and then we are from the Lagrangian coherent structure, LCS, what we call it. We try to compare, because this data I wanted to show LCS region, because this is very, very important from the oil spill point of view. You can see the oil spill is a major problem in many oceans. So now we are trying to casting oil spill trajectory through this LCS method, and the surface current data what we are using for CMMS operational level. So that is one, you can see the example, and this operational product is available from our side, as I was talking about from other data product like mosdeck.gov.in, the oil spill. You can see this product whenever oil spill is there, we try to monitor these things. Yeah, so these are the surface level data. Now I'm talking about the subsurface also, because satellite data is normally giving the surface, but using the numerical models as well as some of the techniques, you can derive some of the parameters for the subsurface. So in this 3D ocean subsurface field, we are trying to derive using the sea surface temperature, sea surface salinity, as well as sea surface height. So all this data has been used through this quasi-geostrophic methodology. And then we try to see that whether we can derive some of the other temperature salinity profile data, as well as some other data through this method. And then for that purpose, we have used a comparison of this data to the Copernicus climate services data. And all these things I'm showing on the right hand side, bottom side. You can see the citations also, where you can get more about this, how this data is being used, and what are the products we are using. So in addition to that, these applications, the climate science is one of the major things. So for the climate science also, we are using this data, Copernicus data. In this slide, you can see that the ocean heat content, one of the major parameter for the cyclone or the hurricane studies. So for that, how this data is important from that point of view, long-term data, whether we can see more energy is there in the cyclone energy in the Bay of Bengal or Arabian Sea. That type of study we have tried to do mostly in the La Nina years. Yeah, and then also because earlier presentation there was query on the projections, as well as whether we can have sea level or the signified or different product projections using this CMS data. So that also we have tried to use, whether we can see what is the sea level prediction in the particular region, because sea level is one from the satellite or water projection is overall the global. But for particular region, whether we want to see whether any rise is there or maybe vulnerability for the near coastal region, or all those. So through this data, we have tried to see sea level anomaly in the east coast of India, as well as we wanted to do some study for the small islands that is near Mauritius. So right hand side, you see the significant divide projection over the Mauritius. Through this data, we have used Copernicus data. Yeah, this is again, you see the for Mauritius other data also, what we have used for the different month-wise. Earlier I was showing that overall for the yearly, but now you can see month-wise how this data is there, whether Mauritius is having any sea for the for Southern Ocean swells are coming, and whether they are having any impact on the particular month, because they are, if you go from the point of view of the shipping and all those things, you have to see that whether anything is there in particular month, so we have to take care. So those things also we try to do using this data. Yeah, in addition to the decadal variability of the extreme wave, because extreme waves are very, very important from the point of view of the, if you want to design any structure, like offshore structure, all those things. So one can predict what is the return period of those structures, that means of 40 years, 50 years, 100 years, because structures have to define for the longer times. So this type of study also we try to do using this satellite data of the past or longer past data, and we have to do some processing of the data, analysis of data, whether it is ready to be used for this projections for the next 50 years, 100 years using different statistical method. So that is also one of the major study we are doing. So overall, I've shown the glimpses only that whatever we are using the CMS data for our applications as well as the retrieval and calibration. So thank you very much. And mainly this research work is possible because of the excellent of my colleagues from Space Application Centers. Many of my colleagues are working with some of citations I've shown also. And this presentation would not be possible by me without their active support. And also, I'm very, very thankful to CMEMS for inviting me for this opportunity, giving to talk to you. Thank you very much.
Thanks a lot for your presentation. It was really interesting to see how you used the Copernicus data in your work. And for now, we have 2 questions for you, so we will start there. The first one, so hello sir, thank you for this informative session. Is it possible to retrieve satellite data on inland water?
Yes, not all satellite data, because I have not talked about that, because some of the data what we are using for the altimeter, these are the very coarser resolution, so those cannot be. But SWOT data, what I was talking about, that can be used for that is being used for the hydrological purpose inland water. That we are also using, and all globally, if you see the SWOT data analysis, it is being used.
Okay, thanks a lot. A more general question about your presentation. So thanks for the presentation. I've probably missed it, but how long have you been working with Copernicus data? For how long?
I can say maybe some Copernicus data, maybe at a decade or so, because different levels of data, because all data we are not using earlier. Some of the data we using earlier, like IVSO and all those things we were using, but now most of the data is available from the CMS, so we are start using that.
Okay, thanks a lot. Another question. What is the resolution of the data you used last?
Resolution, I could not, if you are asking the resolution of the spatial, because resolution different, spatial resolution, temporal resolution, as well as when we talk about spectral. I think you are talking about the resolution, spatial resolution. I think we have used the 5 kilometer data also, because different products are having different resolutions. So I can't say keep each product. Some resolutions are 25 kilometer, 25 kilometers. Some are the 5 kilometers. So like that, different products have different resolutions. So I have to use that based on the what, like sea level. We may have used the 5 kilometer or 10 kilometer. For the reanalysis, we have 25 kilometer or 25 kilometer data.
Okay, thanks a lot.
Yeah.
Yeah, it was the spatial resolution. Okay, so you said the ocean heat content is the major component when we are trying to see cyclone response. Is it the same for upper ocean also?
Yes, because earlier what we are cyclone is supposed to be there only based on the sea surface temperature. It is the only layer, top layer, but it is not that. It is depend upon the layer which is responsible for the overall heat content transfer to the atmosphere. So that's why we call it the ocean heat content from the all upper layer, upper dominant layer. Yeah.
Okay, thanks for the explanation. Okay. So thanks for the insightful presentation. Can you please specify if there is any way in which we can filter internal waves from SLA data?
No, I don't think internal wave from the SL data. I have not seen. So I can't comment directly. But I don't think from SL data internal waves from that. Internal waves, what is being used mainly from this some solitons and all those things one can see, but it's very, very difficult. So what people are using internal waves mostly on the density levels and synthetic aperture radar database people use.
Okay, thanks. Okay, the next question, can we use this data for climate risk analysis for renewable energy like offshore wind?
If I understand correctly, these are the two different things. One is climate risk analysis, other way renewable energy. Yes, for renewable energy, it is being used a lot for offshore wind. I can send you also some of our research papers for the how much energy is available at different locations, and for that normally we use for the satellite wind data, and then because that is available not very near the coast, it is a resolution is coarser, so then we take it to near the coast based on the which satellite, like earlier using 25 kilometer 25 kilometer, then we transfer it to the near the coastal region, and then see how much energy is available near the coastal, and which is the better place for the offshore energy that we have done.
Okay, thanks a lot for the explanation. The next question is more about where you work. So could you please elaborate about ozone space edtech?
Oh, yeah, this is the startup. I started working since 1 year. So this is startup mainly working for the education for the students as well as researchers about the space. What is the data is there? What is the overall opportunities are available? What people want to, because space is a huge thing. Some people talk about only the satellite. Some people talk about applications. Some people talk about the stars and all those things. So we are starting from the very kids level to the graduate level. So depending upon the what type of students are there, what type of researchers are, we take the courses, very short courses presently, and seminars, and we talk about like the stargazing also we do with them students, so they get fascinated about what are these things. So like that we have started, and we are thinking of going for the applications also, because some applications what we are doing is space application center and other centers uh, research. So for those research we are trying to update, or maybe for the directly to the users that we can do, so that some of the products we are thinking of applying and then start using them.
Okay, thanks a lot for the explanation. We have another question. Could you elaborate a little bit more on the use of real-time data for oil spill reliefs work? Did you use Copernicus marine data to do the same?
Yes, I showed that Copernicus data, we have used the surface current data from the CMMS. What is earlier, these two slides I had shown, one is the oil spill itself. There also I have written for the LCS, we have used the Copernicus data, as well as for the generation of LCS product itself, we are using. So yes, we are using it.
Okay, thanks a lot. Thanks a lot for the answer. I think that was the last question about your presentation. So thanks again for joining. You have plenty of kudos in the chat also for your nice presentation. And thanks again for accepting the invitation.
Thank you.
Yeah, so now we will go to the coffee break. So we will take a small 10-minute break. For the participant, feel free to take a look at the polls next to the Q&A section. We've prepared a fun work cloud to get to know you better. So yeah, you can answer the work cloud, so with a few words if you wish, and we will be back in 10 minutes after the break. See you! Welcome back, everyone. So we hope you had time to enjoy the little break and that you are ready for the next user testimonies. And we will start with Lars Hole. So welcome, Lars. Thanks
Thank you.
for joining us. And yeah, we will let you begin your presentation whenever you're ready.
Thank you. So my presentation is based on a paper that we published a couple of years ago about the simulation of marine plastic from the Mekong River using Copernicus marine data. So there seems to be some delay here. There we go. So this was a publication by the main author was my master student, Man Zung, from Vietnam, and it was a collaborative effort between our institute, the Norwegian Meteorological Institute, and the Hydromet service in Vietnam. So I work for the Norwegian Meteorological Institute. We have about 500 employees at different regional offices, and our main task is to safeguard life and property in Norway. And in quite a few years, we have been involved in capacity building projects in Asia and Africa. And we have had close collaboration with colleagues at the Hydromet service in Vietnam for more than a decade. They have about 3,000 employees, and they do observations, research, and forecasting of weather and climate. And the main task for them is also to safeguard life and property. And Norway and Vietnam has a lot in common. We have long coastlines and a lot of activity at sea, near coast and offshore. So the study area of the publication was, of course, the South China Sea or the East Sea, which is surrounded by some of the main contributors to marine plastic in the ocean, like China, Thailand, and Vietnam. And we focused on the emissions of marine plastic from the Mekong River. 6 of the countries bordering to the South China Sea are among the 10 biggest contributors to marine plastic in the world. So, but we focus solely on the plastic from the Mekong mouth to the South China Sea and to look at the fate of the marine plastic. So for the trajectory studies, we used our open drift model, which is an open source framework for ocean trajectory modeling based on offline Lagrangian particle tracking method. So this has been developed by the Norwegian Met Institute for over a decade. And it has many modules for marine plastic, oil, search and rescue, ship drift, long-term pollution, icebergs, and so on. And it has been used worldwide, from the Gulf of Mexico to the Arctic. So for forcing data, we need both wind input and good ocean model input. And we used three-dimensional CMEMS products on the boundary for the ocean modeling, and then ROM's ocean model inside the boundaries. And then the wind data we took from ECMWF reanalysis. And here's a summary of the forcing data. We also got good data from the discharge rates from the rivers, which was also essential in this study. So yeah, you can also read more details about the forcing data in our paper. The reason we choose the Copernicus product was that we have experienced that it provides better results than other global models like HICOM. So here's another summary from another study from this year, actually, by a student called Bente Mørman, which is about to be published, and it shows that Mercator products from Copernicus give a better score for drifter data than, for example, HICOM. So we looked at different factors affecting the marine plastic distribution. So, for example, wind drift factor, we included a realistic wind drift factor from the literature, and compared with simulations without the wind drift, and we see that the the results were quite similar. So the green dots here are with the wind drift, and sorry, I can see the color, but the black is with wind drift and the green is without the wind drift. But we see clear differences between summer, when you have the summer monsoon from southwest, and winter when you have the northeast monsoon. And then the effect of river flows were quite significant, both in winter and summer. So we see that the plastic particles were much more distributed during when we had the river flow input. We also looked at the effect of vertical mixing. So we had a realistic vertical mixing in the model, and we see clear difference in the distribution when you have no vertical mixing, where all the plastic stays on the surface, and when you have a vertical mixing, then the plastic goes more to the south. And we looked at the effect of sinking rates. So with a sinking rate terminal velocity of 2 meters per day, the plastic was distributed over a large area. But with a larger terminal velocity of 5 meters per day, a lot of the plastic ended up on the seafloor close to the mouth of the Mekong River. And the geographical distribution was smaller. So to summarize the results, including realistic data for vertical mixing and sinking rates, our study shows that when you simulate over several years, almost half of the plastic from the Mekong River actually ends up in the Philippines, 47%, 14% in Vietnam, 24% in Indonesia, 8% in Malaysia, and then there is a rest of 7%. So yeah, the plastic goes quite far, as we know. So this was a complex task with the various forcing data. And to do a model study like this, we depend on high quality and easily available forcing data. It's a key factor. And it was a coordinated effort between Hydromet services in Vietnam and Norway. And the work was carried out as a master thesis at the University of Bergen by Man Zung. And much more details can be read in this paper, open source publication from 2023. Thank you very much. I'm open for questions.
Thanks, Lars, for your presentation. We will go to the question. For now, we only have one. I think people are probably reading the paper at the same time. So the question being, could you do this study in other areas?
Yes, the open drift system is very flexible. So as long as we have forcing data, we can do this in any area. So we have done a similar study outside Mozambique recently, for example, including drifter data.
Okay, thanks. Good to know. A question about the validation. Have you validated this drift model? I guess so. It's probably detailed in the paper also.
Yeah, it's detailed in the paper, and we have done a lot of drifter studies. But of course, the wind-related parameters are complex when it comes to marine plastic, because some of the marine plastic is at the surface. And of course, when it's below the surface, then there is no wind drift anymore. So yeah, in this study, then all the particles were on the same size, and they were like sinking slowly to the bottom. So the wind drift was not significant here.
Okay, thanks. And a question about the wind parameters, as you mentioned. Could you please specify the various wind-related parameters aside from wind speed that are being measured from Norway and Vietnam?
Yeah, the wind drift factor is, for oil, for example, it's typically 2%. So yeah, it depends very much on the object you study. So for ship drift, the wind drift factor can be much more. Rescue fleet floating at the surface. We use this same model system a lot for search and rescue. So I encourage everybody interested in trajectory modeling to check out the OpenDrift website. And yeah, there are a lot of details there about the model system.
Okay, thanks, Rod. I guess we can put the link in the chat also for people to take a look.
Yeah.
Okay, another question. So this time on the type of things you observed, can this be applied for other types of litter, or is it only applicable for marine plastics?
No, it can be applied for any type of litter. We have this ocean drift module that we use, for example, when we compare with drifter data. So we have carried out, we build our own drifters, and we have carried out a lot of comparisons with the surface drifters. But you really need to know the wind drift factor. When the object is at the surface, then the wind drift is really critical.
Okay, thanks. A question about the plastic that you observe. Where do you think the plastic comes from? Which company produces the most plastic? Did you study what type of plastic you saw, or was it just following the plastic on the coast?
No, we didn't study the details of where the plastic comes from, the producer and so on. So
Okay.
But this has been published in other studies for people analyzing plastic found at beaches. For example, in Norway, most of the plastic is from the fishing fleet. The plastic is on our beaches.
Okay, thanks a lot. Okay. What is the minimum water depth that your model works? Can it run on coastal areas?
Yes, we use it a lot in coastal areas. For example, when it comes to oil spill, then of course the beaching of the oil is very essential. So yeah, it can be used all the way into the coast.
Thanks a lot. I think this one is a question about the last slides you presented. Does the percentage indicate the accumulation of plastic in the area?
Yes.
Yeah. Okay, another question. What difficulties will be met if you run this kind of model at real time at this geographic level?
It's not because the OpenDrift model has a graphical user interface, so it can be used in real time because you have forcing data available.
Okay. Okay, thanks. Okay. Next question. So, sorry if I just missed this detail, but how did you determine that it is marine plastic and not other suspended matter?
Yeah, we just represented plastic by a certain amount of particles, several million particles. So yeah, was of course a theoretical study. So
okay, okay, thanks. So this one is an open question. I'm not sure to understand. Can anyone simulate research using the OpenDrift model?
Yeah, the OpenDrift model is open source, so I encourage everybody to look at the website in GitHub. Sorry, I didn't include a link, but it's easy to find when you search OpenDrift trajectory model. And yeah, you can set it up. It's coded in Python, and you can run it. After a few minutes, you can install it and do your own simulations. It's very easy to get started with OpenDrift.
Okay, thanks. Okay, we have a few more questions about the presentation. More open question, actually. What are your thoughts on using this product in the seafood industry in order to sustainable harvest?
I'm not really sure I understand this.
Maybe to track fish, I would say, but I'm not sure that's the point of the question.
There is a module for fish eggs and larvae. We have used it a lot in Norway to study the drift of fish eggs, because the fish are spawning in a certain area and the eggs are drifting to another area where the larvae are hatched, and so it can be used for this kind of study to investigate fish stocks. Okay,
good to know. Thanks a lot. Okay. Another open question. Have you any idea how much plastics is gathered in the Bay of Bengal and what are the most affected areas, estuary or deep sea?
I don't know the Bay of Bengal in detail. I know in Vietnam they have a lot of activities on gathering plastic on beaches. So I guess the only place you can really gather plastic efficiently is at beaches.
Yeah.
When it's not easy to collect plastic in the open ocean.
Yeah, except if you go on like the big edges you have at the center of the Pacific, maybe, but yeah.
Yeah,
It's,
if you have some areas with
yeah.
accumulation. But
You need to have a boat or. Okay, I think we've this last question about your presentation. Can you explain, sorry, more regarding the timeline of the study? How long does it usually take for data collection and analysis?
if you have experience, you can start the simulation in a couple of days, if that was the question. But this was a bit heavy calculation, so we needed to use high-performing computers. So yeah, this type of simulation over several years, you cannot run on a laptop.
Okay. Okay, thanks. I think that was the last question directly intended about your presentation. So thanks again for joining us today in the presentation.
Thank you. Very good questions.
And thanks a lot. And yeah, so thanks again for joining. And we will go to the last use case of today, which is, so hi, welcome Shihe. And you can start your presentation whenever you're ready.
Okay, hello, I'm Shihe Ren from National Marine Environmental and Forecasting Center of China. I'm honored to be here and share our work about SST front based on Copernicus marine data in the South China Sea. It's a little bit delayed. Oh, good. So in the beginning, I will give the brief introduction of my institute and NMEFC is China's national authority for marine environmental forecasting and disaster warning. As an operational institution under the Ministry of Natural Resources China, we provide the marine warning and forecasting service, including storm surge, tsunami, wave, sea ice, and ocean current, temperature, salinity, and wind forecasting product, and so on. Oh. So, sorry. So we provide the products and service for the many applications, such as polar and oceanic expeditions, deep sea resource development, and open ocean shipping, distant water fisheries, marine ranching, and the military operation, and for the marine project of offshore wind energy and oil platform operation. Now let's go back to the topic. This is the outline of my work. And in the beginning, I will explain what is the ocean front. Ocean fronts are the dynamic boundaries that separate water masses with different properties, such as temperature, salinity, or some nutrient content. And these sharp gradients in physical and chemical conditions have important impacts on many aspects, such as the marine military, air-sea interaction, and marine ecosystem for the fishery and marine environment. So these two figures show us what oceanfront is in the real life. The left figure shows a different water color near the estuary, which is salinity, which water color fronts. And in the right figure is the boundary of salty water and the melt water of glacier, which is salinity fronts. And mesoscale and ocean fronts and mesoscale eddies, these mesoscale features is a key ocean process, which they are very important, not just for the expanding our forecasting abilities, but also for the meeting the needs of the industry, like fishery and ecology. In recent years, our institute has developed a fully operational predicting system basing an automated detection method and statistical analysis. We also carry out the product evaluation and validation. We complete a full chain of mesoscale front forecasting product, like the red figure. And this figure shows we based our work, we built a platform, a web platform to provide our forecasting system. Oh, sorry. Oh. Sorry, it's a move so fast.
You can use the keyboard arrows. It will be easier than the mouse.
Yes. Oh. So this slide shows the progress of oceanfront forecasting product of our institute in recent years. We have developed from the South China Sea and to the Northwest Pacific, and then we plan to expand our product to the global scale. And in this talk, I will focus on the application of Copernicus data, which is the circle in the red line and the green line. We focus on use the reanalysis data of GLORIS and SST observation of Austria. Both of these two datasets have a very good quality and high resolution, which is very suitable for the study of oceanfront. And the comparison and validation of ocean fronts will be the focus of my talk. I will start with the front detection method because we need an effective and accurate automated method for the detecting fronts. We need to highlight the stable front position, and we need to highlight the strong fronts. And in the right figure shows the frontal detection method of the daily snapshot. A solid black line shows the frontal line, and the gray shadow shows a frontal zone. And for the diagnostic results, we also need to calculate a front parameter, such as frontal length and width and the amplitude and the area. This is frontal width, and this is a length, and the area with the right line is the area. For the high resolution dataset, we also add some pre-processing and post-processing procedures to ensure the detecting results is balanced as frontal continuity and position accuracy. For example, in the left, we separate the frontal branch like this. In the red dot, it's a branch pixel, and because if we had branch, it's very hard to calculate this front parameter. So we separate one front into two according to the front's physical patterns. And the example in the right shows when frontal segments merge, and this procedure can link the very short frontal lines nearby into one long front segment. And these two figures shows the improvement of our method. After the post-progress, we get more reasonable results, which has less front number and longer frontal length compared with the classic Kenny method, and showing which can highlight the primary frontal patterns. And the detail of my front detection method is elaborated in this paper. published in 2021. And the comparison of glories and Austria include these parts: a monthly front gradient magnitude and frontal parameters, and frontal occurrence frequency include the raw grade and beam grade. And for the frontal spatial patterns occurrence frequency, the n front means the number of frontal occurrence days, and the n total means the number of the total days. So the frequency equals n front divided by the n total. It can show the spatial patterns of the front occurrence. And this slide shows the climatology of 10 long-term average climatology of the 10 years, the frontal gradient magnitude based on the Austria and the glories. Generally, both data sets shows similar frontal patterns. The output reveals several prominent and persistent front in the South China Sea, including the Guangdong and Fujian coastal front, and here is Taiwan bank, and some nearshore like the coast of Vietnam, and the front magnitude of glories is slightly stronger than the Austria, which shows Austria data is more smooth due to the interpolating method, and also the frontal activities in the South China Sea shows very distinct seasonal cycles. In the winter, you can see in this line, the front reach their maximum intensity, and during the spring, and this line shows spring, it's a transition season. Front strength declines, and the coastal fronts generally weaken in the summer. And though frontal structure persistent in some key upwelling zones like Taiwan bank around the Hainan Island and on the coast of Vietnam. By the autumn, the front activity diminished to its seasonal minimum. And the 10-year average of frontal metrics of the length, gradient, number, and width and area are shown in this slide. All the metrics demonstrating the similar seasonal cycle with in summer, when the uniform SST patterns shows a decreasing of frontal magnitude, and the front are shorter, and hence more fronts are detected. In the contrast, frontal lines are detected as long and continuous segments in the winter, which explains the seasonal trend of frontal numbers. Generally speaking, both the number and width and area of Austria are more than the glories, and the length and gradient of glories are longer and stronger than the Austria data. And for the front occurrence frequency distribution and seasonal patterns are very similar with the result of the magnitude, and they are stronger in the nearshore and weaker in the central basin. This is a frontal area frequency, and their seasonal cycle is also very similar, and the high frequency in the winter and the low frequency in summer and autumn. And this is a frontal line frequency, and it shows the similar features. And in order to compare these two data, because the glories and Austria, their grade is not uniform, so we interpolate the front frequency into an uniform grade. For this case, we use a 0.5 degree, and we calculate the bias of these two data sets. And the yellow grade means the glories overestimate the front frequency, and the blue means the glories underestimate. In the near shore, where main fronts occurs, glories underestimate mostly. But in the central basin of South China Sea, maybe because of some transient features such as mesoscale eddies shows glories capture more transit fronts, and so austere capture more stable nearshore fronts. This is for the daily snapshot in the typical read seasons, January and September. And we for this we also add the model data of center is based on the ROMs with 130 degrees, which also is a very high resolution model data. So we can see in the January, Austria and glories capture similar front structures in the near shore, but the Austria and glories shows more continuous coastal front. In September, the stable fronts near shore becomes weak and more transit features in the basin. So for the daily results, we need to change from the seasonal patterns to the daily snapshots. So we need a class 4 day-to-day match validation matrix. So we build a matrix to build a validation matrix. It's called hit or miss validation in an uniform bin grid. So we can assess the accuracy of the front in a forecasting product based on observation. And this metric can offer the information of the frontal processing in the model, so allowing to the user to evaluate the structure of the mesoscale feature simulated by the forecast. Oh, sorry. For this, this is the raw data of the observation and model, and for these two figures, it shows graded results of the ocean front. The yellow grid means the ocean front. We can then, in a uniform grid, we can compare whether whether a point is forecast or not forecast. And based on the results, we also build some metrics such as the bias and threat scores, false alarm rates, and miss rate and forecast accuracy to quantify the validation skills scores. And this is these two figures shows a long-term validation scores and climatology results. We can also see the scores also show very strong seasonal cycle, and in the winter the score is high, and in summer the score is relatively low. And for the austere as an L4 product, in the cloud cover region, the SST results are made from the smoothing method, which can reduce the SST gradient. And maybe which is maybe not the true condition. So in our work, we also compare the L3 SST product versus L4 product. For example, we use the Moody's L3 data, like in the central figure. As we can see, the green square means we forecasting it's successful. So as we can see for this our model, for the L3 Moody's data, the green square is more than austere results. So maybe in the work future, we will focus on the L3 data, because the L4 data, it can reduce the gradient by the extra manually. I think it's maybe not a very proper means. As a brief conclusion, so we developed a robust ocean front detection algorithm optimized for the high resolution SST data, and we also compared frontal statistics using CMEMS analysis data and the satellite observation data. And at last, we proposed a daily front matching validation framework to assess the front's spatial and temporal accuracy. Oh, it's finished. That's my talk. Thanks for the inviting from the Copernicus, and thank you for attention.
Thanks again, Shihe, for your presentation. It was really interesting, and we have several questions for you, so we will go to that part. The first one being, do you work on anything with cumulative impact assessments in your work?
I'm a little confused about what cumulative impact. Oh, maybe I guess they mean such as the fishery or the other.
I would say so, yeah.
But so sorry, we didn't do that. But it's our future work to. But it's a limitation for us. It's very hard for us to get a real the fish amount of the data. So this maybe it's our future work.
Okay.
Good.
Okay. Good to know. Thanks.
Mm.
Yeah. Yeah, okay, it's fine. Is there a possibility of a front occurring in Indonesian waters? What is the probability and when?
So my work is mainly about the South China Sea, and it's include a part of the Indonesia waters, but it's not our focus. We most focus on the coast of China, so maybe the audience can give it a try.
Okay.
Yeah.
Thanks for the answer.
Yeah.
Okay. Have you considered using salinity parameter for front detection, and can we apply your methods for nearshore areas?
Yes, we have tried to use the salinity as a parameter to detect our fronts. It's suitable, but we need to change the threshold of our method to suitable for the different parameters. And for the nearshore area, yes, I think my method can works because we as I mentioned, we add some post processing procedures. It's mainly for the to solve the problem of the high resolution data. Yeah.
Okay. Okay, thanks for the explanation. I think it's clearer now. Okay, another question. Can thermal front detection algorithm be integrated into real-time navigation or marine forecasting system?
I think yes, but I think for the ships above the sea, they don't pay much attention to the thermal front. I think for the submarine, it's there maybe the front, and maybe the most important is the ocean sound induced by the front is their focus. I think it's the scale is more detailed.
Okay.
I think yeah. But yeah, it can apply into the not only the surface data, and also can use the data under the sea. Yeah.
Okay, thanks a lot for the explanation. We have this question. Can users use discrete Fourier transform in integration with your algorithm for this type of forecasting?
Sorry, I'm not very familiar with the DFT algorithm.
Yeah, I think it's like to simplify a signal, basically, you know, to decompose it into cosinus, sinus, and everything. But yeah, maybe I can just put the question aside, and if you want to look into it.
Okay.
Yeah. Thanks. Okay, so the next question about the type of data. Why didn't Odyssey data used? Why didn't you use any Odyssey data? Is it similar with Austia?
This Odyssey data is also in the Copernicus website. I'm not very familiar with this data. It's because in the beginning, we start with the L4 data, and then Austia data, it has a long time spanning and a very high resolution. So we use this data first. Maybe later we will try the different data.
Yeah, I would say
it's a good option. Yeah.
Yeah, Odyssey is quite new, so maybe you didn't have enough data to do your study. Okay, a more open question: what is the significance of this study?
As I mentioned in the slide, so for our center, we provide the ocean forecasting product. Beside the classic elements such as the temperature, salinity, and we also need to expand our product to the mesoscale products such as the mesoscale eddies and fronts, and and also for the ocean fishery and especially the military, the demand of the mesoscale eddies and fronts are very strong. So this is, I think, I can answer this question. Yeah.
Okay, thanks. A more open question, I think, related to an area or where you can do your study. What are your thoughts on the Philippine Sea?
I think it's more complex because in the Philippine Sea there are a lot of island and very detailed topography, and maybe the fronts there are stronger than in the central of the South China Sea, and maybe you need to adapt the threshold of the detection method. Yeah.
Okay, thanks. So we have time for 2 more questions. What is the minimum temperature gradient used to detect the thermal algorithm? I guess thermal front in the algorithm.
Yeah, for the South China Sea, I use the 003 degrees per kilometers. It's a gradient unit. Yeah,
okay. Okay, thanks for the precision. And the last question, so is China's SST data accessible through platforms or services that conform to the IHO framework? I don't know what is the IHO framework, so maybe you know.
I can try to answer this question. For China, we also have the ocean satellite such as HY2. We also can inverse the SST data, but we are working on the merging data and L4 merging data, but it's not open in the net internationally. Maybe later we can collaborate with the Copernicus data, and we can share our data. Thanks. Okay,
thanks a lot. That was the last question for you. So we will stop there. Thanks again for joining. It was really nice having you.
Thank you very much.
Thank you. And yes, so thanks again to everyone for their presentation, and to you participants for your participation. So we are reaching the end of today's session. So yeah, we hope you found the session useful and informative. Before you leave, I just want to remind you that the practical session will be the day after tomorrow. So even if you haven't had time yet, I invite you to check the full tutorials and to practice if you wish to. So they are available in full on the event website, and there is a tab at the top where you can find the Jupyter, QGIS, and Air sections, all of them using Copernicus marine data. So on day 2, we will have the presentation of this tutorial, so our experts will be able to answer your question if you have some. Finally, I also want to remind you that there is a section on the website next to the Q&A reserved to the polls. So we would really appreciate to have your feedback on today and what we could provide in the future. And yeah, thanks again to everyone, and we see you in 2 days' time. Bye.